All right, we're going to go ahead and move into probability of at least one. Also, probability of some. There's many more ways you can do this. Probability of two or more. Okay, so several different ways that you can say at least one. But there's a very important shortcut and a very important way to think about how to do this problem, or else it could take you forever to get all the proper combinations done. So we're going to take a look at how that is, and we're going to build that. Here we go. So let's find the probability of getting a heads on the coin flip twice in a row. We've already talked about that. It's that. Now, the next, I want you to write out the sample space for all the possible ways and outcomes that you can have when you flip two coins. So I have done that here. Heads, heads, tails, tails, heads, tails, or tails, heads. All right. So look at what has happened. Of this sample space, what's the probability of getting heads twice in a row? 1 out of 4 possible items in the sample space. So that was the same as when we had done this computing up here. All right. So that idea we're going to kind of carry over into this next one. So here we have what's the same sample space of it getting at least one tails. Okay, so here we go. At least one tails. So that means I can have two tails, or this one tail, or this one tail. And so that's 3/4. There are 3 out of 4 ways I can have at least one tails. And so another way that we can think of this is that to have at least one, it's all of the possible combinations with the exception of this piece here. And this piece here is the probability of no tails. So here's how we can think of this. The probability of at least one tails is everything except the part with no tails. Also, everything minus the probability of no tails. There were both heads. So here's how this works. 1 minus that probability that none of the two flips are tails. And none of the two flips are tails means both of them are heads. And we know how to calculate that very simply as a half times a half. So that's a fourth. So then we are going to do 1 minus 1/4, and that's how we get the 3/4. It's always going to be that way. So it's going to be the entire combination, all of the things, with the exception of that one that is none of the things you want. So let's take a look at this. Let's do a sample space with 4 coins. It gets pretty gnarly pretty fast. So I have it drawn out for you. Here we go. So here are the ways you can have no tails. Here are the ways you can have one tail. So you can see here's the 4 combinations where you have one tail. All right. Here are the ways you can have 2 tails. Okay, so there's 2 tails on that one and 2 tails on this one, and so on. Okay, and then the next one is all the ways that you can have 3 tails. And then, of course, this last one is all 4 tails. Okay, so now let's move forward and let's see where this takes us. So what is the probability that you flip 4 coins and you get at least one of them are tails? Okay, so you flip 4 coins and at least one of them are tails. Well, I have that here circled or boxed in purple. That's all of these combinations with the exception of that one time when none of the 4 coins are tails. So let's see what that looks like. At least one tails is all of the possible combinations except for the one case when none of the 4 coin tosses are tails. So here is how I write that. Probability of at least one tails, 1 minus the probability that none of the 4 flips are tails. And I know that none of them are being tails is a half to the 4th power because it's half times half times half times half. And that's how I get that. So all of this over here is 94%. This would have been a nightmare to add up to see that there's 15 out of 16 combinations. So you had to come up with that sample space. That is the key to being able to do at least one. So we're going to take a look at this song that goes with at least one. So here we go. The probability of at least one. Listing all those combinations is not fun. You know, all those 16 combinations we had to list. Not fun. What happens, you know, because if you had 5 coins, I think that's even more. 32 combinations maybe, or maybe I think it's 64. Crazy. It gets really big really fast. I don't want to do that. Probability of at least one. Listing all the combinations is not fun, and I'm not going to do it. Probability of at least one. It's easier with 1 minus the probability of none. That's how we're going to do it. Probability of at least one is 1 minus the probability of none. Okay, so let's go through this last section here. Here we have the fair dice tossed 3 times. What's the probability at least one of them is a 1? So that's probability that none. Now, I write out the details here because you can get lost in the details if you just write probability of none. Years of experience have taught me this, that if I just go 1 minus probability of none, what do you mean none? Then we get lost in what the details are that we're doing none of. We are saying none of the 3 tosses are 1. And so 1/6 is 1. So none of the 3 tosses is 1. And that's how you come up with that. Next, if approximately 13% of the population is left-handed, what's the probability that at least 1 of 10 is left-handed? At least 1. So that's 1 minus the probability that none of the 10 students is left-handed. So they're all righties. So that's our 0.87 to the 10th power, and that's how we get that. I think I've just got one more here. So here we go. If approximately 35% of the vehicles registered in Parker County are trucks, what's the probability that out of the next 5 vehicles that come to that stop sign, out of the next 5, some of them will be trucks? Some is another way of saying at least one of them will be a truck. So that's 1 minus the probability that none of the 5 vehicles are trucks. Then that will be that whole entire combination of all the other things that could happen, with the one exception of no truck, no truck, no truck, no truck, no truck. So probability that all of the 5 vehicles are something else, being something else, is 65%. So that's how that plays out. All right, so that brings us to the end of your at least one experience. And so if I went a little too fast on those, then you can kind of stop and think and process through these answers there. But then you're going to follow up with your first assignment in Intro to Probability. Good luck.